So next topic under thermal stresses is how to determine thermal stresses when bars are in series with both ends in fixed and subjected to temperature change, let's say delta T. So here we consider one steel bar connected with copper bar and both ends are fixed. We know that to understand how much will be the elongation due to this case when these are subjected to a temperature change delta T. So to understand this, we know that whenever both ends are at fixed, we can draw FBD of these shafts. So this one is FBD of steel and this one is FBD of copper. We know that due to temperature change, when they are free to expand, if they are free to expand, it will expand by a certain amount, and we know this expansion is equal to delta L, that is equal to alpha L delta T. See, these both are expansions due to change in temperature, that delta L is equal to alpha L delta T. Of course, this alpha is for steel and alpha for copper will be different. So these two are having different values, okay. But as these are fixed at both ends, these bars are also subjected to some, if I draw its FBD separately, these bars are also subjected to some compressive forces. Why compressive? Because they are subjected to expansion, heated. So there will be some restriction due to these supports, and they will exert, the supports will exert some compressive force P from both sides. As when bar in series, if force P is acting on an entire system, then on each bar the same force of P will be acting. Now if I try to find out total change in length, we know that as these bars are fixed in between two supports, total deflection, that is total change in length of this entire system must be equal to 0. Now we will try to find out this delta L is nothing but delta L of, let's say, steel plus delta L of copper, and it is equal to 0. Now how much change in length of steel? We know that here there is not only compressive force but also it is subject to some temperature change delta T. So when we talk about steel, the change in length of steel is due to temperature change, which is equal to alpha L delta T. So I can write here alpha L delta T is nothing but change in temperature of steel, change in length of the steel due to change in temperature. But it is subject to compressive force, so there will be some compression, okay, and it is, as it is compressive force, due to this force the change in length. So remember, this is nothing but change in length delta L is equal to PL upon AE. So there are two types of change in length. One is due to thermal stress, due to temperature change, and one is due to this compressive force. So for steel and copper. So for steel, this alpha L delta T plus or minus, it is minus because force is compressive, minus PL upon AE of steel. This is for steel, plus for copper also. For copper again, thermal change in thermal expansion is alpha L delta T, and this one is due to force P, minus PL upon AE is equal to 0. So this is the expression used to solve problems on this kind of in this case. So what you get from this, there may be some unknown like force P. If you get P, then you can find stresses. A more simplified way we can write like this: alpha L delta T of steel, I will take to this side, plus alpha L delta T of copper, this is of copper, is equal to, if I take to this PL upon A term to this side, it will get, you obtain PL upon A of steel plus PL upon A of copper. So this is simple expression for obtain from the concept of total change in length is equal to 0 as both bars are fixed at both ends, subjected to temperature change, as well as due to change in temperature there is some compressive force exerted by the supports on this bar. So this expression is used to solve numericals on this topic. One small topic we need to discuss in addition to this concept. Here we consider that bars are in series and both ends are fixed, subject to temperature change delta T. In addition to this, it may be possible that there may be bars are in series and there is some gap is given. So yielding of support is given. So this gap is given. Then how to solve this kind of numericals? Again, both ends are fixed, but some there gap is there. So in this case again, this formula remains same, because we know that in this case, whatever change in length, let's say again consider steel and copper bar and subject to temperature change delta T. So what happened here? Due to change in temperature, thermal stress will produce, that is equal to alpha L delta T of steel plus alpha L delta T of copper, and when it expands, it is subject to some force again. When it expands, there is some compressive force acting from this side and compressive force acting from this side, that is P. So concept remains same again. But what happened here? This delta L, that is total change in length, in this case is not 0, because when it expands, this gap will maintain, because up to here, up to this gap, it will expand freely, and then there is restriction. So this delta L is nothing but a gap. So what my formula in this case? It will remain same as like this, but it is not 0. Instead of delta L is equal to 0, what I can write now? So total change in length of steel plus total change in length of copper is equal to gap. So how much it is? It is nothing but alpha, let's again consider by two ways, alpha L delta T plus minus PL upon AE for steel plus alpha L delta T minus PL upon AE for copper, but now it is not equal to 0, but it is equal to gap. In more simplified way, we can write like this: alpha L delta T of steel plus alpha L delta T of copper minus gap is equal to PL upon AE of steel plus PL upon AE of copper. So this expression is used to solve numericals when gap is given in case of bars in series subject to thermal expansion. So what is addition here? In this case, this gap you need to consider, because there is gap, so up to gap it is free expansion and then there is restriction. So these are the two equations that we can use to solve numericals on bars in series with complete prevention, that is both ends fixed like this here, and the second case when there is bars in series but some gap is there. So equation number 1 and this equation number 2 are used to solve numericals.